Good day, everyone, and welcome to this Gradle webinar. I'm your host, Oliver White, and joining us today for Writing Tests is Hard, Fixing Them is Harder, is the wonderful Trisha Gee. Trisha is a Java champion, author, and principal developer advocate at Gradle, and I believe she also co-owns the best ice cream parlor in Seville, Spain as well. You've likely seen her speaking around the world. Today, Trisha is going to lead us through the challenge of doing tests well and the importance of being able to know exactly what the heck is going on when you witness flaky tests and test failures. Along the way, she'll demo examples, explain why flaky tests are not only annoying but uniquely detrimental to developer productivity and happiness, and bring AI into the conversation too. So while we wait for everyone to get settled with their coffee, tea, fizzy beverages, etc., we've got a few housekeeping items to go over. Today's session is being recorded and will be shared with you next week, so you don't have to ask. It will take about 40 minutes plus time for a Q&A afterwards for live attendees, so please send your questions early into the Zoom chat or to me privately, and we'll do our best to address them at the end of the session. Lastly, this webinar and all of our DPE events are made possible only by the support of our hundreds of happy Develocity customers, including Revolut, the UK's most valuable fintech startup and global neobank, in quotes. Their Android team leverages Develocity Build Cache to keep their builds time at least 75% faster than before, and continues to use build scan and failure analytics to observe their entire build toolchain. Currently, they have over 30 open engineering positions around the world, so check out their careers page. Okay, that's it from me. Let's now hand it over to Trisha. Trisha, thanks for joining us today.
Thanks for having me, Oliver. I don't think I've ever been on one of your hosted webinars before, and I think, we've known each other for a long time.
Very long. And it's great to sit down together finally at last.
Yeah,
after 15 years, I think. So this is great.
I'm happy to be here, and I like your radio voice. It works really well.
Oh, well, thank you so much.
All right, well, I'm going to get started. I don't have to introduce myself because Oliver did a fantastic job of doing that. I do have to say, Oliver said, how long is this going to be? I'm like, about 40 minutes. It's only 96 slides that I'm going to try and get through in 40 minutes, plus 2 live demos. What could possibly go wrong? And if you have seen one of my testing talks before, it's a variation on that. So there'll be some stuff which is familiar, and I've also cut a load of stuff out. So maybe it will hit 40 minutes. So yes, I'm Trisha Gee. I'm a lead technical evangelist. That's my official job title. I like to call myself a developer advocate. I can't advance the slides because now I've lost my cursor because Zoom likes to do that to me. I am a Java champion and author, but the key thing really for this presentation is that I've got about 20 odd years development experience writing tests, having tests fail on me, and trying to figure out what on earth is wrong with my test. Before I start that, I do want to give the context about productivity from Gradle's point of view. So Gradle is pioneering this thing called developer productivity engineering, a software development practice used by leading software development organizations to maximize developer productivity and happiness. Why is this relevant? Because when we talk a lot about developer productivity, we at Gradle have been talking about things like build times and reducing build times. And when it comes to build times, it's often about the build and test cycle. And that's where I'm mostly interested, in the testing bit rather than the building stuff. So this kind of does lead to the question of, do tests make you more productive? Because I think there's an argument for perhaps testing. It's important. We know testing is important, but there can be some levels of frustration around automated testing. Sometimes we find that running our tests is very slow. And sometimes we find that writing tests or debugging tests is a very frustrating situation. So this is really what I wanted to talk about in this presentation. So I asked a bunch of people on social media, what slows down your testing? And the results were somewhat surprising to me. I really did think that a lot of people were going to say that running tests takes a long time. But actually what we found is a lot of people have trouble writing tests in terms of they feel that slows down their ability to, do anything with tests. The debugging and fixing tests was actually a relatively small amount of time. But what really did win, if win is the right word, is that unreliable tests really messes up our flow as developers. It's really something that slows us down when we can't rely on the results of the tests that we've written, that we run locally, or that we run in CI. So the thing I really want to talk about today is the idea of writing tests, and I'm going to address the sort of debugging and fixing tests along with the flaky tests in one chunk, if you like. The main thing here is that flaky tests is my favorite rant, so I get to spend about 10 minutes just complaining about how flaky tests are terrible and you need to do something about them. So the first thing we're going to talk about is that writing tests is hard. Writing tests does slow us down because it's a thing we need to do. So I'm going to give you a bunch of tips to help in this area. For anyone who knows that I used to work for JetBrains and did a lot of work with IntelliJ IDEA, it will not come as a surprise to learn that I'm going to do a demo of how to use your IDE to write tests a little bit faster. Live demos, what could possibly go wrong? Everything always works just fine. So I'm going to find myself a class which does not yet have a test. I'm going to use navigate to test. If you look at the bottom of the screen, the keyboard shortcuts do flash up and they'll tell you which keyboard shortcuts I'm using. So we use navigate to test. This class doesn't have a test, so I'm just going to get IntelliJ IDEA to create a new test. And it's not just IntelliJ, by the way. A lot of IDEs do this kind of thing, but IntelliJ is the one I know best, so this is the one I'm going to demo. So it'll create me a new test. I'm going to add it to Git, and then I can create a new test method. But IntelliJ IDEA by default will give you the bare minimum to get running with a test method. This isn't quite good enough for me. I know what I want my test methods to look like, so I'm not going to do that. I've already created a custom live template which creates tests the way that I want them to be. And this is a real live template that I use all the time when I'm creating tests. I want my tests to use display name. I want to have a given when and then. I want them to have a particular structure. So my test is going to say, should get the Twitter handle. Oh, you know what? Let's say user handle because it's not called Twitter anymore. Should get the user handle from the message, which we used to call a tweet. And then I'm going to press the wrong button in the wrong place. So now I've done that. I don't have a given. I'm going to go straight to a when. So I'm going to get from the user service, I'm testing this method, get Twitter handle from tweet. I need to give it a tweet, example input. I get IntelliJ IDEA to create the constant field for this. I have on my clipboard history, the information I want in the tweet. I'm just going to paste that in there. What have I done wrong? I do not have, oh my goodness. Having one of those days. I'm going to have to use the mouse, which I really hate doing. And close that in quotes. What I do want to do, because this is huge and it's super in my way, and I'm really interested in the tests themselves and not in the example data. So what I'm going to do is I'm going to wrap this in an editor fold. I'm going to call this example input, and I can't spell today, and fold that away. So then I can just fold away irrelevant information in my test and just carry on with writing my test. Then I'm going to get my username, and then I'm going to do my assertion. So I'm going to assert equals. I always want to check which one is expected and which one is actual because different testing frameworks split these around. So my expected is Trisha, _Gee. And then IntelliJ IDEA is already suggesting some things here. This is IntelliJ's full line code completion, which is fairly new. It is ML code completion, but it doesn't dial out of your IDE. It's all locally run and it doesn't send your code back to the server, which is a good thing. So I actually, so you can use this. It kind of ruins a lot of my demos because the full line code completion kind of does exactly what I want without me getting to demo all the stuff I wanted to show. But, it's useful as a developer. So I'm going to do that. And I actually do want to take username. So we're going to run that and my test passes. Now, I'm deeply suspicious of tests that pass. So let's just see if we can break it first. Just make sure it is passing for the right reason. And it is because my actual is Trisha Gee and my expected is Trisha Gee 1. So we fairly quickly, and I know this is a fairly dumb example of a test, but I'm not going to spend, half an hour writing a real example of a test because that's going to take away time from the rest of the webinar. The point is that if you know your IDE, if you know how to use code generation, code completion, some of these code suggestions, you can write the code fairly quickly. particularly for generating tests when you already have code that exists. I tend to like doing TDD, so I tend to do it the other way around. I tend to write my tests first in IntelliJ IDEA and then use code generation to create my production code and fill in the correct answers, if you would. Okay, so that is using my IDE. Of course, it is 2024, so I do need to talk about AI. It's a mandatory part of all presentations this year, so I have to show you some AI stuff or I don't get my badge as developer advocate this year. So let's show you some AI stuff. I'm going to be using JetBrains AI Assistant because it's embedded inside the IDE, and JetBrains is kind enough to give me a license for AI Assistant, so it's kind of easy for me to use. But what I'm going to do is I'm going to generate a unit test from existing code that does not have a unit test. Let's have a look I'm going to go to this method here. Now in this class does have a test. I can show you. It has a mood service test. This method does not have a test. I know that because it's marked as unused, so it can't possibly be being tested. I'm going to use Alt-Enter, use the AI actions, and I'm going to generate unit tests. Now, this is the most interesting part of the demo because every time I do this, the AI assistant will give me a different answer. So let's see what answer it gives us this time. This is the demo that I have to kind of wing it and figure out what's going on. So it has found that I already have a mood service test, so that's nice. It's going to add tests into my existing test class instead of creating a new test class. It's going to update the inputs. Weirdly, it's putting my new tests at the bottom. When I ran this demo an hour ago, it put all the tests at the top. But, whatever floats your boat. And now I'm going to... So let's see, what have we got here? It's testing the happy case, the sad case, sad and happy case, and a case which doesn't have a mood in it. And the method names aren't dreadful. It's following my pattern of having a display name and a method name which begins with should. That's kind of fine. We could try it. We could try out, can you add a test for a null input? I don't know. Maybe that will work. Let's see what it does. Like I said, these demos are always fraught with danger. What's it doing now? Doing everything from the top, putting everything back at the bottom. But it replaced all my existing tests. That's not what I wanted it to do. Oh my goodness. Don't do that. AI, it makes you super productive. It totally saves you all this time and makes it so much easier to write stuff. What's it doing now? It's just totally changing everything. Okay, fine. Please add in all the test methods you had earlier. I swear I could have written all the tests by now. Oh, I broke it. I was probably too polite and I said, please. We didn't even get to the point where I get it to change to use parameterized testing and where I get to run it and find that it doesn't compile and it doesn't run. But there you go. AI totally works. To be fair, I'm actually using a beta version of IntelliJ IDEA here with a beta version of the AI assistant. So, don't be too harsh on JetBrains. I don't want to spend forever doing this because I've got like 96 more slides to go through, but let's see if it gets there. There we go. Look at that. I just had to be nice to it and give it some time. Just be patient with the machine as it finished. Oh yeah, there we go. Great. And then one of the things I like to do is say, please use parameterized tests, and it will rewrite it in the style that I want, in theory. Anyway, AI, totally fine. Nothing to worry about here. It definitely makes our lives easier. I'll come back to this. Let's carry on with the rest of the slides. So, as we've seen, AI can be good for generating the mundane or predictable code. The full line code completion is very good inside IntelliJ IDEA. It's really good for generating your sort of first pass at unit tests. What I discovered about these unit tests that it generates, though, is it's quite naive, and it puts in a very simple string. And when you run the test, it's the wrong shaped string, and it needs to be more like JSON with various values in. So you do have to go in, obviously run the tests, and make sure that it's doing what you think it's doing. It's pretty good for generating test data because you can have conversations with the AI to figure out what the data looks like and how many different edge cases you want to generate. And it's way better than you doing it by hand. AI can sometimes consider edge cases we haven't thought of. So I've found that when I'm generating unit tests, it's quite good at doing the sort of empty string, null string, but also things like what happens if someone put a number in there, or what happens if someone put in something that's too big. So it can consider edge cases. It doesn't do all of them, but it sometimes comes up with stuff which you wouldn't have thought of. So I find that AI can be a decent companion, like a pair programmer, but it's definitely not going to replace you, because you're still there thinking, okay, is this test valuable? Is the behavior that it's testing actually the expected behavior? Is the test giving me anything valuable? So basically, you still have to be thinking about what should the test do, what should the behavior of the system be, and how do I make sure I provoke that behavior of the system on top of the AI writing some code. The other thing to bear in mind is that AI just lies half the time. So I was asking ChatGPT for some quotes when I first wrote this presentation, and it said that it gave me some great quotes, including a great one from Agatha Christie. And I was like, oh, when did Agatha Christie say that? And ChatGPT said, no, she never said that. I just totally made that up. So everything that AI gives you, you do need to sort of just give it a second guess, second check, and make sure it really is what you thought it was. Another thing to consider with code, with productivity tools like AI, like code generation, like the IDEs, is there's this myth around what is really slowing us down in terms of our productivity. This is particularly prevalent when it comes to AI. So there's this article about the myths of generative AI, and it states, the productivity myth suggests that anything we spend time on is up for automation. The importance and value of thinking about our work and why we do it is waved away as a distraction. So this myth implies that everything we do is possible to automate. And we've already just kind of touched on this. The automating of writing the tests is not taking away the pain of testing. It's not typing the keys which slows us down. It's thinking about what those tests are, what they should be, and what the behavior should be, which is the thing that takes the time. I used to work with Dave Farley, and Dave Farley used to say this all the time, especially when we were talking about pair programming. He always said the keyboard is not the bottleneck. And what he means is it's not the typing that slows us down. Having two developers at one keyboard doesn't slow us down because there's only one keyboard to type the code into. It's really the thinking which is the bottleneck, and the designing and the process of doing software engineering, which can be faster with a pair, like another programmer, or may potentially be faster if we learn how to work effectively with a tool like generative AI. So speaking about that, maybe in order to write our tests more quickly, more effectively, or in a way which is less boring for us, we can bring a friend. This quote is from Agile Testing Condensed, and it says, we recommend that the developers who are good at writing efficient, maintainable code work together with the testers who are good at specifying test cases to automate tests. So they're saying, and I've done this before, I've paired with test specialists in writing tests. And this is great because as a developer, you're like, right, it should do this. I want it to do that. I need these inputs. And the testers go, the users are going to do something idiotic, like come at it from this angle or put one of these things in. And you're like, oh, right. I never even thought about testing for that because surely users aren't that stupid. And it's not that users are stupid. It's just that they often interact with our system in a way that we don't expect. And testers are really good at anticipating that. So this reminded me of something I read in organizational physics, which is about sort of personality profiles. I guess it's sort of a Myers-Briggs kind of thing for organizations. But I found it kind of interesting and useful. As individuals, we might inhabit more than one of these sectors. We're not always a stabilizer or whatever. But I find this matrix helpful in terms of thinking about different types of people who work on teams. So when we're doing development, when we're coding, when we're trying to push stuff out there, we tend to be an innovator, producer kind of area. We tend to be working at a fast pace, and we tend to be just trying to push stuff out there. When we're testing things, when we're thinking about the quality of the code we're writing, we need to be much more in the stabilizer area. And you can see stabilizer specifically says quality control. That's kind of a personality trait that's required for someone who cares about the quality of something. And a stabilizer has a structured approach and works at a slower pace. So when we're writing automated tests, we either could be pairing with someone who's more naturally in that stabilizer role, or maybe we need to get our headset into the stabilizer mindset instead of into the producer or innovator mindset. And a quote I think which meshes really nicely with this is from the American poet Dorothy Parker. And she says, "Creativity is a wild mind and a disciplined eye." And I think this applies really nicely to development. Development, coding, programming, we know it's a creative endeavor. We know it's not just about, bashing the keys and getting code into the computer. It's something we have to think creatively about. And if a poet says creativity is a wild mind and a disciplined eye, we know that it takes these two things, this kind of innovation, this creative thoughts, these crazy ideas out there. That's really important for creating something new. But you need the discipline to implement it correctly. You need the discipline to make sure that it does what you thought it was going to do and it doesn't lose the user $300 million or whatever. You need the balance of the wild mind and the disciplined eye. My final thought around writing tests is that it's important to invest the time in writing the tests correctly or better in order to save time troubleshooting. And we'll see this in action almost straight away. So let's talk about how fixing tests is hard. When a test fails, often the first thing we think is, what is this test anyway? This example shows two of my least favorite patterns when it comes to automated tests. One, the test name is called test increment, which I hate because it doesn't tell you anything. What am I testing about an increment? Am I testing it does increment or that it doesn't increment under certain circumstances? How much should it increment by? What should it do if it's not incrementing? Under what circumstances does it increment? And often when you have a test method that's called something like this, you find it does all of those things. Test increment does, happy case, sad case, all the edge cases, and a bunch of other stuff as well, because it's just checking everything the increment might or might not do. And the other pattern, which I really hate, is assert true or assert false. Because when assert true fails, it says, I expected true, but it was false. And you're like, okay, what did you think was going to be true? Why is it false? And what does that mean? It gives you no information about where that came from or what the expectation means, really. And it gives you no idea about how to fix that problem or what might be going wrong. So your test needs to tell you what is expected and why so that you understand what to do when it fails. And I think this is something we don't always think about when we're writing tests. So I know I'm talking about troubleshooting tests right now, but we are circling a bit around the area of writing tests in the first place. When you write a test, the goal is not necessarily to make it go green, although if it goes green, that's great. The goal is that it should break under certain circumstances. It should break if the behavior changes. It should break if the data changes. It should break if someone did something that unintentionally affects that area of the code. And when it breaks, it needs to tell you why it broke. It needs to tell you which circumstances it expected and why they're not there anymore. So when we write our test, we really need to be thinking about what is this telling me when it breaks in the future. So some of my personal preferences around this kind of area are to use, you saw this earlier in my demo, to use should on method names and to use a display name in JUnit 5 so that I can have nice descriptive names for my tests. I like to use assert equals so I can more clearly see the difference between the expected one and the failing one. And there are some other patterns I like, and you saw this again in my demo. I really like given, when, and then, because that really helps me figure out which part of this test is the setup of the criteria that need to be in place in order for this test to function. What is the thing I'm actually testing, and what are the assertions that check that it did what it was supposed to do? I like display name, as I told you, and I also like assert all in JUnit 5 because assert all will run all of those assertions and tell you I've got 5 assertions here and 3 of them failed. Whereas usually the default way for JUnits would work is that it fails on the first assertion and it goes, oh, well, this failed. So you fix that and then it fails on the second assertion. You go, well, I didn't tell you because I didn't get there, but this one failed too. So assert all is a good way to make sure you run all the assertions and it gives you feedback straight away of half of the assertions just don't work. And so it's broken in this way. So we're talking about fixing tests, which means that we sort of need to think about why tests fail. And when I was thinking about this, and I've been thinking about this topic for over a year now, My initial instinct was when a test fails, it's for one of two reasons. Either the production code is wrong or the test is wrong. But in actual fact, of course, it's somewhat more complicated than that, as always. And it's not as simple as something changed on one side or the other. A lot of these things are kind of like all mushed together in the big mishmash, which is our development environment, our CI environment, our whatever environment. But in some ways, it's actually simpler than this. The test started to fail, assuming it passed in the first place, because something changed. And that something could be the production code, the test code. It could be a refactoring or structural change, which could have affected production and test code, or even architecture. It could be the data changed. Either the test data or the data in production is now different. Could be the infrastructure changed, particularly if we're running it in CI and the platform team made some changes around the CI environment. One of the things that I think is unexpected that can cause failures is if load or usage changes in, for example, CI. So I've seen this when I was working on a high-frequency trading platform. As we start to add more tests, as we start to run the tests more frequently, as we add more code, the load on the CI system made the tests more unreliable because the latency starts to increase and wait time for things like the UI to come up increases. And so all of these things lead to failures where you haven't changed anything in the code. And it can be quite unexpected for us when we're trying to debug these problems. So when we're trying to find out why a test failed, our first thought is, whose fault is this? Of course, we don't say it that way. We say to our boss, I'm triaging this problem. But triage is ultimately like, who's responsible for fixing this? Now, given those things that we talked about, if the problem is in the production code, the test code, or as a refactoring thing, it's probably my fault as the developer. It's probably me who has to fix this thing. If the data changed, it might be something that I have responsibility for. It might be something that a DBA has responsibility for, if we still have DBAs, or, some architect or something. It might belong somewhere else. If it's infrastructure, load or usage, it's probably something that the CI team or the platform team is going to handle. But we still need to tell them what the problem is, where it started, and maybe how to address that issue. In order to do that triage, you need data. Data is the most important thing. So, for example, you want to be able to see when that test started to fail. Most CI environments will give you that kind of information for the CI environment that ran that test. But what you don't always have is a sort of holistic view of everywhere that test ran and every time it passed or failed, including local passes or failures. So a tool like Develocity, which is Gradle's other tool that isn't the build tool, will help you see, at this point, my test started to fail. And it does that because it has a whole bunch of build scans. For every time you ran the build and test, whether it was locally or whether it's in CI, you have a list of all of these passes and failures. And so you can track down the patterns in any of those passes or failures. And then if you drill into that particular failing build, for example, it will give you a whole bunch of information, like when this ran, it had this operating system. It was using this version of Java. It was using these particular flags on the build. So you need all of the information about the build that ran the test and the history of the running of that test in order to figure out what's changed in order for that test to start failing. Step 2, fix it. Easy, no problem. So I've been thinking a lot about how to troubleshoot, or how do I troubleshoot failing tests? And of course, a lot of it is just kind of prodding at the code until it does what I want it to do, or shoving stuff into CI and hoping that I fix the problem. Of course, the best thing is to take a scientific approach. Hence my Ada Lovelace quote of, your best and wisest refuge from all your troubles is in your science. So you can take an iterative approach to figure out what's wrong with this. Again, I'm talking mostly around stuff that starts failing in an environment that we don't necessarily control. So not necessarily our local build. The first thing that we're going to do is obviously investigate the failure. And for this, we need data. And we've already talked a bit about this and the idea of something like a build scan, which will give you all the information about the build that ran that test. Which environment did it run on? Which operating system? Which versions of Java? What exactly was the task that was run? What is the performance of that? And then you can kind of get an idea of what was the environment that ran that build. And there are other things you can use as well. So this is a build scan. By the way, build scans are free from Gradle, and there will be a link at the end if you want to have a look at build scans. But obviously, I also have a lot of experience using the IDE. So I wanted to give you a couple of other things that you can look at in the IDE, which can help you track things down. So inside IntelliJ IDEA, for example, well, look, it did generate my tests. Let's accept all of those. Inside IntelliJ IDEA, there's a feature called the stack trace, analyze stack trace. So I can click on that. I can paste in, that's not what I want. I can paste in a stack trace like this IO exception. And if I say analyze, then it will open it up into as if I'd actually run it. So I now have clickable links to the various different bits and pieces in the stack trace. So this way I might be able to get a log from production or somewhere like that and put it into my IDE and be able to navigate through the error that is found in order to identify, more easily get to the places in the code. Now, I know that's a sort of fairly straightforward thing because I could just as easily copy that from there and I could go to can tweet service line 38 and it will take me there anyway. But the idea of being able to have the whole stack trace and navigate through it fairly quickly does make troubleshooting a bit easier. The one caveat here is it does help if you have the same version of code in your IDE that you've pulled the log from. Otherwise, you're not going to have the line numbers matching up. Another thing you can use is the remote debugger in IntelliJ IDEA. So sometimes you might want to attach your IDE to a remote service that's running the code that's a problem. There's a whole series of like tutorials and videos on how to use the remote debugger if that's something that you're interested in. It's just worth being aware of the fact that it does exist. So tools and data. This is a way to investigate the problem. Once you've investigated the problem, you need to be able to reproduce that problem. And probably there's going to be a certain amount of iterating over this investigate, reproduce, find data, try and figure out if I can reproduce the problem locally. And here, automation is your friend. Obviously, if your application is more fully automated, if you're using Docker, if you're using a bunch of other tools to naturally bring your application to the same state, that does make it a bit easier to reproduce problems. When I was working in a bank in London, our system used event sourcing, so we would be able to replay events through our local version of the application to get the application in the same state that the production system was in. So this was a good way of automating getting from zero to getting to where the problems were occurring. And then once you've reproduced the problem, you're going to want to make changes and rerun things to see if your test passes. Probably this is not just one step. Probably this is also a hopefully small feedback cycle and a short iteration in terms of make changes, run it, did it pass, and so on and so forth. It's really important to learn how to use your debugger in order to do this most effectively. Not only because the debugger will allow you to step into the code and see exactly what's happening inside your code, but you can also use the debugger to poke in values manually and so on. So if you don't know the starting point that got you to that point in the test, let's say, for example, the test is horribly dependent upon some previous tests, you can use the debugger to poke manual values into the application state to get it to a situation to try and provoke the error that you're seeing. So your debugger will be a really helpful tool in terms of reproducing the problems that you're finding. Which means you need to really be able to build and run your tests locally. If they're running in a different environment, you do want to be able to reproduce them locally and build, debug, and run them locally. And that way you get nice, fast feedback loop. Otherwise, you end up, sorry, I pressed the wrong button. Otherwise, you end up having to do a much larger feedback cycle of make changes, push the changes somewhere else, hope that maybe the test passed, investigate what happened, and go on this big, huge feedback loop instead of the nice, tight, local feedback loop. So your goal when you're trying to troubleshoot tests is to aim for fast feedback and easy reproduction. So someone I spend a lot of time talking to tests about is this man here, who happens to be my husband. And I asked him how he troubleshoots test failures in his system. And he spends a lot of time working with Android, which includes like emulator run tests and web tests, which have got a lot of end-to-end testing. And he said 99% of the time, 99.9% of the time, the best way to troubleshoot a test is to rewrite it so it's smaller and faster. He just finds it insanely frustrating to be troubleshooting a failing emulator test when a lot of the time is just spent bringing up the emulator, rerunning the test, and having it fail in a way which is not understandable. And the way to figure out what's going on is often to break that test down into smaller unit tests, and then you find you've also fixed the problem. So now you've fixed the problem, everything's fine and happy. Except that the thing that was biting most people around automated tests was unreliable test results, our flaky tests. The problem with flaky tests is they make us lose faith in our whole test suite. They erode our trust. There was a study done I don't have the year on this, but a few years ago about the developer experience of flaky tests. And it stated, our analysis revealed that rerunning the failing build and attempting to repair the flaky test were the most common actions. Okay, that sort of seems reasonable. If we think it's a flaky test, we are going to rerun it to see if maybe it passes next time around, or hopefully we're also going to try and fix it. But what they found was developers who experience flaky tests more often are more likely to take no action in response to them. They're not going to rerun the tests to see if it's flaky. They're not going to fix the tests. They're not even really going to check actually failing tests, because by now the flaky tests that have been eating away at their trust in the tests of the system mean that they no longer trust any of the results. So they're just like, well, we just have flaky tests, so it's probably fine. It'll probably go green next time. So flaky tests are toxic to our whole team environment. And they certainly mean that we don't know about the quality of our code, and we don't really feel very motivated to invest time in writing good tests, because most of the time we just ignore the test results anyway. So I want to give you a 3-step process to fixing your flaky tests. And the first step is to find your flaky tests. If you don't know which ones are flaky and which ones are failing, you can't fix your failures, which you really should do, and you can't identify which ones are flaky and might need some special attention. So a tool like Develocity will tell you the difference between tests which are really failing and tests which are flaky. And by flaky, I mean when you rerun them, they pass the next time around with no changes whatsoever. So there are 2 mechanisms that Develocity uses for this. One is retries. So there are a few different ways of setting it up, but you can set up Gradle or Maven to automatically rerun a failing test to see if it's flaky. And Develocity will see, well, you ran it 3 times and it failed once and, failed twice and passed once. And so therefore that's a flaky test. It'll be flagged as flaky. The other thing it will do is Develocity will look across different builds and go, well, the same code ran here and here and here, and sometimes it passed and sometimes it failed, and it will flag those as flaky as well. So there's different mechanisms for identifying flaky tests. So now you know which ones are your flaky tests, you can completely ignore those flaky tests. Do not ignore your flaky tests. Just because you know which ones are flaky doesn't mean they're not still toxic in your environment. Doesn't mean they're not still eroding your trust in any test results. So the next thing you need to do is, ideally fix them, but probably more realistically quarantine your flaky tests. So run them somewhere else, or put an ignore annotation on them with a specific tag to remind you to come back and fix them. Or we wrote an annotation in one of my old places. We wrote an annotation which was ignore until, and you give it a date and you say, right, over the next 2 weeks, I'll definitely fix this flaky test. And so it would ignore it for 2 weeks. And if you haven't fixed it within 2 weeks, it will pop back up and start failing again, which is a good way to remind you to fix your flaky test. So next step is to fix your flaky test. If you add a new test and it's flaky there and then, or if you're working on a test which was working and it becomes flaky while you're working on it, now is the time to fix it. Not later, not some other team that's going to fix it. If you made a flaky test, make it unflaky before you move on to the next task. However, more realistically, especially if you have only just started using tools to identify your flaky tests, you probably have a backlog of flaky tests that you need to tackle. So you need to make time to fix those flaky tests. There's a few different ways of doing that. One, when they impact you directly, like I just talked about, or to attach them to related functionality. So if some place order tests are flaky, next time you come to touch the place order functionality, you set aside time to also fix your flaky tests, because you don't know if your new functionality is working if your tests are flaky, so you might as well fix them. You can set aside time with flaky test days. This is what Gradle does. Gradle schedules days where we just work on flaky tests. You could add flaky tests that you need to fix to the backlog, or you can use things like 20% time or any time you have for fixing tech debt or any cleanup time to tackle flaky tests. I'm a bit reluctant to mention 5 because I suspect that means things will never get done. But if you have time to work on your own projects, then maybe flaky tests might be one of those projects that you work on. I want to give a quick call out to causes of flakiness, but we don't really have time to explore all of this. I do want to say that when it comes to flakiness, not everything is something that we as developers can control. So things like environment and integration points, we can't always control that. If we can minimize some of the things which can cause flakiness, there are good practices that we can use which will actually help minimize flakiness. So tests should be isolated. That will help you. If the cause of flakiness is actual system behavior, if it's a real race condition in the production code, as happened somewhere where I worked, it can be really hard to track that down. But that just means it's even more important to look at the causes of flaky tests, because it might be a real production problem which is causing that test to intermittently fail. My old boss, Dave Farley, has a video on the 5 causes of test intermittency. So if you're interested in finding out more, I suggest you have a look at that video because he goes into it in much more detail. And the final thing I want to leave you with is to write better tests. This is not a judgment. This is just a thing that I remind myself all the time. Writing better tests will make our lives easier. So let's focus a bit more on writing better tests. This includes using all of the software engineering practices we know for writing production code. Solid, separation of concerns, don't repeat yourself, descriptive naming, all of those things that we apply to production code also applies to test code. Now, there is a tension between these different things, but that's to be expected. That's what software engineering is all about. So, for example, there may be a tension between having very clear isolation between tests and the speed at which the tests run. Because if clear isolation means setting up an entire database for every individual test method, then the performance of the overall test suite is going to suffer. So we need to understand where those tension points are and where is the correct balance for us for our tests. Kent Beck wrote something about desirable unit tests. All of the information that's in these slides, there'll be a link at the end of the slides to a page on my website which has links to all of this stuff. But Kent Beck wrote about the traits of desirable unit tests. And I don't really have time to go into these, so I'm just going to skip really quickly over this. The point here is that unit tests have some very specific behaviors which makes them unit as opposed to integrated. And this is where the testing pyramid comes in, and everyone hates the testing pyramid because they're like, oh, I don't really have integration tests. I have service tests or I have performance tests or whatever. But I don't want us to get too hung up on the words that are used in the testing pyramid. The important point is that you should have many more fast and isolated tests than you have slow and integrated tests. And that's partly because fast and isolated tests are easier to troubleshoot, easier to debug, easier to reproduce, and less likely to be flaky. And partly because, well, actually, really, that's the only real reason. That's why you want to push that way. However, of course, there's a need for integrated integration tests, end-to-end tests. There are contract tests. There are different types of tests which have to be integrated. But the idea is to not integrate by default. If you can mock out things like your databases. You can stub things out. You can use test harnesses. Not everything has to be integrated. You want to push things down the testing pyramid where it's possible. And the final thing I really want to talk about in terms of testing best practice is it's important to refactor and delete tests as well. These are production codes. This is production level code, the same as production code. So you do need to refactor and delete tests too. So Angie Jones, who knows a lot about testing, as she said she regularly deletes tests that no longer add unique value. I think we have a lot of fear around deleting tests, and I think we should not fear that. Having tests which weigh us down, that we don't understand, that intermittently fail and give us no value, are a drain on our productivity. They're not helping us at all. So, in summary, I'd like to leave you with a quote from Kent Beck. Testing is Xanax for programmers. It's an anxiety-reducing technique. I know that testing can slow us down. I know writing tests is hard. I know writing good tests is even harder. And troubleshooting failures is extremely difficult. But when we have a good, reliable, trustworthy test suite, it makes us feel better as developers. We can safely refactor things. We can safely add features. We can safely delete code, knowing that our test suite has our back. So tooling can help us in terms of writing good tests, in terms of troubleshooting failures. We talked about tooling in terms of the IDE, in terms of build scans, in terms of Develocity, in terms of AI can help us here, in terms of automation like Docker and tools like that. These tools and techniques can help us be more effective and more productive with tests. However, there is a time investment in writing tests because there is thinking involved, and no amount of tooling and automation is going to prevent the fact that somebody somewhere needs to think, what should it do? How should it behave? And what should it look like when it fails? And if you invest time in writing better tests, they will be easier to debug, less flaky, and they will better document your system's expected behavior. And I think this is one of the most misunderstood parts of having automated tests. My husband, again, gets quoted twice in this presentation. He was talking to his intern and he said, testing is not only for checking the system does what it's supposed to do, it's for documenting the expected behavior. But he corrected himself and he said, testing is not for checking the system does what it's supposed to do. It's for documenting the expected behavior. Our automated tests are living documentation of what the system should do. Those tests should pass, and when they fail, we should be investigating why the system no longer behaves as expected. So, thank you very much. If you want to learn more about Gradle's free build scans, go to scans.gradle.com. If you're interested in finding out anything more about the information that's been in this presentation, go to that link for the QR code and that bit.ly link. That page has all the links, information, slides. There's some videos of previous or different versions of this talk too. So most of the reference information should be there. Oliver, are there any questions?
Oh, Trisha, you know there's a lot of them.
I'm so glad I finished with time to actually take questions.
Yeah, that's great. We've gotten till the end of the hour for those of you who are interested in sticking around. For the rest of you, follow Trisha's advice. Check out scans.gradle.com. You get to use it for free. We've already done over 110 million scans for developers all over the world. It's really an impressive number, and it grows more every day. The comment, the chat while you were presenting, Trisha, is filled with lots of great comments as well as some questions too. So let's actually go all the way back to the beginning. There was a flurry of questions when you were showing your IDE Twitter test example. And if we can skip back to that part of your presentation, you don't have to go there, but positioning your mind to that. One question is, are we actually hitting the real user service to get the Twitter handle in this case, or was that manufactured, let's say?
So this is an old demo from a long time ago. And what I did is a long time ago, I created a client that connects to real Twitter when it was Twitter a long time ago, and consumed a whole bunch of real Twitter data, which I then put into a there's a flat file somewhere of JSON information. So it's real Twitter data, but that user service, and this is about trying to use unit tests where you don't need integration tests. The reason why I consumed that data and put it in a flat file is so that I could more quickly test my services. I didn't want them to have to connect to Twitter to test that they did what they did. I can use standard data that looks exactly the way I expect it to make sure that the service starts up, that it can parse stuff that goes into it. It uses WebSockets, that it parses stuff correctly that goes into the WebSockets. So it is real Twitter data, but it's from a flat file because it's a much faster way to unit test the service.
So it doesn't actually need to reach out to, x.com and it doesn't rely on any real-time data because that's not necessary for the purposes of your unit test, and also it would slow things down considerably.
Exactly. But I do have a Twitter service. I haven't tried this one for a long time. It almost definitely doesn't work because it's old. But I have a Twitter service with some tests, and those ones are intentionally slow because it's supposed to test connecting to Twitter. And so that's the thing, like modularizing your this is kind of a little bit pre when we were talking about microservices, but modularizing your services and having the dependencies, having the responsibilities well separated means that you can run some stuff very fast, and only the stuff that has to be slow is slow.
Okay, I understand. Thank you. Another question related to your use of the IntelliJ AI, or the beta version of its AI. The question is, where is the AI pulling its data from? And I'm not sure if you actually would know, but it's a curious question.
Yeah, so it's JetBrains AI assistant, as far as I understood it last time I was reading about it, it is based on, so they've changed a lot of this. There we go. It is based on ChatGPT, but it is also augmented with a whole bunch of stuff from JetBrains. There is an agreement that they are not going to train their AI on your code, if that's also the question. But that's the question you always have to ask yourself about any of these AI assistants. Like, are they sending your code back to their servers and then training the model on it? That's an excellent question. There's quite a lot of information about JetBrains AI assistant, and in the latest version of IntelliJ, which this one is, they've changed some stuff and improved some things. There's something else they do, actually, which I don't know if it's going to work. Let's see if I can get it to work. In theory, yes, you can. You can say, write me a new test for unhappy messages. And in theory, it will, you can write it inline. There you go. That's quite cute. So that's new in the latest version of AI Assistant.
Excellent. That's cool. Thank you for explaining that. There was a comment in here. It's not exactly a question, but I wanted to read it out. The attendee wrote, "One thing that scares me about AI-generated tests is that they're based on actual code. So it tests that the code works as it actually works.
Yes.
Probably tests should be derived from what you know should happen instead of from the code itself."
Yes. I 100% agree with that. And again, it's actually one of the reasons why I quite like doing TDD, AI or not AI or IDEs or whatever. In my opinion, it's more helpful to start from the requirements of what the system should do. And your test should get its information about what it's testing from the requirements from the business analysts or the users or whatever. That's the source of truth for the test. The test should not be getting its requirements from what the code does. And this is the reason why test-driven development is, in my mind, a different way. It's a different way of thinking. But when I write code, when I write code first and it implements things this way and it parses the user this way and it does these things, when I come to write the test, I am going to write the test that checks the code does what I wrote it to do. Okay, that's cognitive bias. That's how it works. That's why, in theory, you should write your tests first. With AI, it has no choice. It absolutely must write the tests that test the code does what it does. So maybe it's a good way of getting coverage up, but it's not a great way of asserting that the application works the way it should work. But it is quite a good way of asserting that the application does work that way. So you can use it for like legacy code, for example, to generate a whole bunch of tests, and it can say, this is how the application works. And a developer goes, oh my God, I didn't know that. And perhaps it shouldn't work that way. So yes, the AI will only generate tests, should really only generate tests that prove the application works the way the application works.
All right. Well, it looks like we've got a way to go until we can deliver that other sort of nuance. Next question. This is a little bit of a multiple choice. It might be a little tough for me to read it out, but the attendee asks, what would be a good way to determine if something is necessary for the test, in parentheses, probably in the quote given, end quote? Should it go into A, the actual test method, B, a non-method called from the test method, C, @, before all method, or D, an external non-test class interface? Gosh, I feel like I'm a professor right now. This is totally unfair.
I'm sure the person who asked that question knows that the answer is it depends. And a lot of it is all about, there's two main things that it depends on. One is how often is that thing going to be reused? So if you're setting up data for an individual test method, so for example, these aren't great tests, but if I'm setting up data for this test method, and it's only used in this test method, then I'm only going to set it up here. because there's no value in putting it in a shared area if nothing else is going to use it. So that's kind of fairly straightforward. So my given for an individual test is only going to set up data for that individual test. Once it starts getting used by 2 or 3 test methods in the same class, you might want to pull that up into either, like they say, either a before or into maybe a helper method. Helper methods can be quite nice rather than in the before, because you might want to, we used to use these a lot when I worked at LMAX. You would say something like, I don't know if any of these are going to compile now. So you might say something like, and actually here's a good example. So instead of having this here, I might want to move this up, and I might say something like get example input where Trisha is the user, or something like that, right? And then you can have a helper method, make sure it's private, and this is just going to return this, okay? And the advantage of this is that it can be kind of DSL-ish. It can be descriptive on what it's doing. So here, and there's lots of different ways of doing this as well. So I might want to say get example input, and then I give in. Oops, I didn't want to do that. I wanted to refactor, and I might want to give in the expected username, and then the method does something around poking the right username into the right shape data and so forth. So really, everything is about readability. And also, to some extent, dialect, if you like. If all of your tests tend to use at before to set up all the data for your test methods, then use at before, because you want the principle of least surprise. You want to know where to look for that sort of information. But if you're trying to move to maybe a more expressive, more descriptive way of testing, you might want to say, well, actually, why don't we move to using helper methods which have got some sort of useful naming. And then things like before class, for example. Before class, you're only going to use that if pretty much every method in there is going to use that data. So database, I've done this before when I worked at MongoDB. You might set up the database in before class because you only want to set it up once. You don't want to set it up every single time that the method is called. So there's trade-offs, but it depends a lot on how often the data is going to be used, and also the sort of standards and consistency across your own code base.
All right. Excellent answer. Thank you, Trisha. We've got time for one last question. What would you do to get fast feedback cycles with a Jenkins pipeline?
Oh, I can't answer that question. I don't know Jenkins well enough. I'll tell you though, Oleg probably knows the answer to that question, but I don't, that's not my area of expertise, I'm afraid.
All right. Well, we'll just leave it up to BuildScan to help you out there. Well, Trisha, thank you so much for your time and expertise today. The feedback in the chat was incredibly positive. You got many thanks from many people. And I just wanted to thank you and our audience for tuning in. If you have any further questions you would like to pose to our team of engineers or Trisha, you can email me directly at owhite@gradle.com. Thanks very much, and we'll see you next time.